Okay students, we had discussed in the last class about the unit weight. So basically we discussed bulk unit weight and saturated unit weight, and also we discussed dry unit weight. Okay, today we will be discussing saturated unit weight. Our next is saturated unit weight, submerged unit weight. The next is 11th one is submerged unit weight. Okay, so this you have to understand a little bit conceptually. What is actually submerged unit weight is, like for example, we are assuming that the whole soil theory or the whole soil layer is under submerged condition. That means whole soil is under water. So what I can understand is, like, if this is my soil layer, this will have soil solid, this will have water, this will have air. Okay, so everything is under the groundwater table. So this whole soil is under groundwater table. So what can I assume is, like, I can assume it to be a spherical body. Let's suppose that it is like that. I've assumed that it is a spherical body of volume V. So we already know that when a body of volume V is there, so it will be asserting some magnitude downward, which is its weight. So its own weight will be nothing but mg, and that will be nothing but what? Rho into V. That will be my mass into g, or it can be called as gamma of this particular body into g. Now what will I take as the gamma of this particular body? As it is fully submerged condition, as the whole body is under submerged condition, we'll assume that this body, all the voids of this volume V is filled by water. So we'll assume that everything is filled by water. So whole voids are filled with water, so it is under saturated condition. So its gamma will be nothing but not gamma T, not gamma D, but it would be gamma saturated into G. Now, according to Archimedes Principle, we know that whenever a body is submerged in water or any fluid, there is a buoyant force that is acting on that body. Okay. What is the magnitude of that buoyant force? That is very, very important. The magnitude of the buoyant force exerted by the fluid or water in this case will be equal to the weight of water displaced by this particular body. So if it is a volume V, obviously it will displace V amount of water. This volume will be V amount of water, but not solid. So what is the magnitude of my buoyant force now? The buoyant force will be nothing but the weight. Weight is again a force, unit of force. The weight of the water collected in that particular tank. So what will be the weight of that water collected? Obviously it is nothing but, this will be gamma saturated into V. So the net buoyant force will be nothing but equal to the weight of water. What is the weight of water? That will be nothing but gamma of water. This will be nothing but the upward force, that is the buoyant force which will be acting, gamma W into V, because that is nothing but the magnitude of buoyant force on any particle. It is nothing but equal to gamma W, that is the weight of water. Weight of water of volume V will be what? Rho W into V. That will be mass of the water of volume V into G. That is nothing but equal to gamma W into G, gamma W into V, because rho W into G is gamma W and into V. So this is the net force acting on this body. So now we very well know that the unit weight, any unit weight is equals to the total weight, total effective weight, you can say, effective weight divided by the total volume. So what is total effective weight? Effective weight is nothing but the effective downward weight at which is this body is exerting. So it is exerting gamma saturated into volume downwards, but also there is a buoyant force acting upwards. So net weight will be nothing but gamma saturated into V minus gamma W into V upon V will be my total unit weight. That is nothing but my submerged unit weight. So that is coming out to be V will get cancelled. That is coming out to be gamma saturated minus gamma W equal to gamma submerged. This is very, very important. You have to remember. Okay students, now let's discuss the next thing. Next thing is the specific gravity for solids. So what is the specific gravity for solids? That is called as GS. So what do you mean by GS? GS is very, very simple to understand. GS is nothing but the specific gravity. What do you mean by specific gravity? That is very, very important. Specific gravity is nothing but your ratio of unit weights. How denser or how heavier a material is corresponding to other material. So what are we comparing? Basically we are comparing two materials. There is nothing but the ratio of two materials. What is the ratio called? This is called as the specific gravity. So we have to say that this material is heavier than this material in some respect. And what is the ratio called? Specific gravity. How heavier or how denser is the other material corresponding to the reference material. Now, the word I am using here is reference material. Generally, we use a reference as whatever is fixed. So we know that, very well know that only one quantity is there which has a fixed unit weight, and that is nothing but water. Water has a fixed unit weight equal to 9.81 kilonewton per meter cube. So if I say that GS, that is nothing but specific gravity of soil solids. Okay, I am specifically talking about soil solids. What will be that? That is nothing but ratio of their gamma. Gamma is what? Nothing but gamma S. That is the unit weight of soil solids. Just the unit weight of soil solid we have to consider in this case, and divided by gamma W, which is my reference. So this will be my GS. If someone asks you what is the specific gravity of water, So what will you say? That will be very easy. That is nothing but equal to 1, because our specific gravity of water will be nothing but gamma W, and difference is also gamma W, that will be equal to 1. Now we can also write it as rho S, rho solid into G, and here we can write down rho water into G. So it is nothing but also equal to rho S by rho G. So it is nothing but also the ratio of their densities. We can also say that this is the ratio of this is rho S by rho W. So it is also the ratio of their densities as well. I told you how denser a material corresponding to a reference material is nothing but called as your specific gravity. Okay, let's move forward. Okay, now if I want to consider, or if someone asks you that what is the mass specific gravity of a soil. Now this was for particularly solids which we were talking about, only the soil grains. But soil, the total soil is made up of 3 particles: water, air and soil solids. So if we include all these 3, our gamma value will change. So what will be our gamma value? Our gamma value will be now taken as the bulk unit weight. In general condition, we know that we have to use bulk unit weight. So that is very, very important to understand that whenever somebody is asking you mass specific gravity, you would take that as G M will be equal to gamma T and respect to obviously gamma W. Now, if someone asks you find out the mass specific gravity under saturated condition, so gamma T will change to gamma saturated and gamma W will remain the same. If someone asks you mass specific gravity under dry condition, the gamma T will be changed to gamma D and you will get this particular value, which is very, very easy to understand. Okay. Okay, students, let's move on and now let's see what are some important relationships which are to be taken considered of. Now first important relationship is Vs is nothing but equal to V upon 1 plus E. Let's see how will we prove it. Very simple proof it is. Simply we will take the most complicated part, that is nothing but V upon 1 plus E. So that will be nothing but V upon 1 plus VV by Vs, and that will be nothing but Vs, because E is nothing but Vv by Vs, we can write it down. So this will be nothing but Vs into V upon Vs plus Vv, and we very well know that Vs, that is the volume of solid, plus volume of voids, is nothing but equal to what? Total volume. So whenever you get the total volume, you can obviously divide total volumes together and you will be getting it equal to Vs. This is our first derivation, most simplest derivation which is there. We will be moving forward in our derivation. Okay, now our next derivation is eta, that is nothing but our porosity, is equals to E upon 1 plus E. So what I'll write as E is Vv upon Vs divided by 1 plus Vv by Vs. So Vv will be equal to Vv upon total volume will be, this Vs will cancel, and that is Vv upon V is porosity only, which is very, very simple to find out. Okay students, now let's look at the next derivation, that is gamma d is equals to gamma t upon 1 plus w. How will I derive it? I'll simply write gamma t as total weight upon total volume, and this will be 1 plus w upon ws. This is nothing but small w, which is the water content given. We very well know that the water content is nothing but equal to ww upon ws. So here I'll write down ww upon ws. So this will be ws plus ww, and ws will also go up. So what is ww plus ws? Total weight, because weight of air is not there. So total weight will be equal to weight of solids plus weight of water. So what will you get? You will get w at the top, and this w and w will cancel. You will get ws by v, which is nothing but equal to gamma d, dry unit weight. When we don't consider the weight of water, that is nothing but called as the dry unit weight. Okay, very, very easy to understand. If you know the basics, see in the exam, I won't suggest you to learn all the formulas. I'll only suggest you to learn 2 formulas, because you cannot learn all the formulas, and I am not requesting you to do that as well. Okay, in the exam, you'll only go with 2 formulas, and rest all these formulas whenever required, you can derive if you know the concept. Okay, it won't take you hardly 30 seconds to a minute to derive any formula in this chapter. Okay. Okay students, now let's discuss the next derivation, which is the most important derivation not only in the geotechnical engineering but in the whole civil engineering, which is the most important formula which I will be using, that is SE is equals to WGS. It's also called as the Sehwag formula, I say Sehwag. So we can also learn by the cricketing term, and we can remember this SE is equals to WGS. Very important formula. Let's take the most complicated one. As GS is there, it is obviously a little bit complex, so we'll take the complex one. So here, if I go here, W can be written as WW upon WS, and GS can be written as gamma S upon gamma W. So GS can be written as gamma S upon gamma W. So this will be again written as gamma S will be written as WS upon VS, because gamma is nothing but what? Weight upon volume. So we can write down as gamma S will be written as WS upon VS, whereas gamma W can be written as weight of water upon volume of water. Very important, very easy. So this WW will cancel, and this also will, WS will also cancel out each other. So what we'll get is nothing but our V, this will be nothing but equal to VW upon VS. Now if I multiply with VV and divide with VV, and if I combine VW and VV and VV and VS, so what is VW by V? VW by VV is nothing but volume of water divided by volume of voids. That is nothing but what? Saturation, S. And what is volume of void upon volume of solids? That is nothing but equal to E. So this is how we derive SE is equals to WGS. Very simple. Here we have to find a trick, that is multiply and divide by volume of voids. Okay students, so apart from SE is equals to WG, you have to again remember this formula. So that is only what I am recommending you. Learn two formulas. These are very important. Okay, so this will be nothing but gamma T is equals to GS plus SE upon 1 plus E gamma W. Let's try to derive this particular formula as well. Okay, so firstly what I will be doing is I will be taking the RHS, this is more complex. So I will write down GS and I will replace SE by GS into W, that is W GS upon 1 plus E into gamma W. This can also be written as GS can be taken out, and this will be nothing but W 1 plus W upon 1 plus E, where W is the water content and gamma W is here. Now here what I am looking at is what is nothing but small w. So GS into 1 plus small w will be nothing but W, weight of water upon weight of solids, divided by 1 plus volume of voids upon volume of solids. So here into gamma W. So this will be nothing but equal to GS into this WS plus WW will be nothing but equal to total weight, isn't it? Total weight upon weight of solid divided by Vs plus Vv will be total volume divided by Vs into gamma W. So it will be nothing but equal to Gs into nothing but Vs by Ws into capital W upon capital V into gamma W. Okay, so this will be nothing but equal to Gs, where Vs upon Ws, Vs upon Ws. This Ws by Vs will be nothing but, this can be written as 1 upon Ws upon Vs into W by V. Whole W by V will be written as what? Gamma T. Total weight upon total volume is nothing but what? Gamma T into gamma W. So Gs can be written as nothing but gamma S upon gamma W into 1 upon Ws by Vs can be written as gamma S into gamma T into gamma W. So gamma S cancel, gamma W cancel. This is nothing but equal to gamma T, which is my desired result, which you can understand very, very carefully. This is very simple problem. We have to just focus on the basics. If we know simple terms, if we remember simple terms, these derivations are not very difficult. It can be derived within a minute in the examination as well. Okay, so if they are confusing you with some formulas or some concepts in the exam, you can hardly invest 2 minutes of yours at max in order to derive that particular result, and then you can use it up in solving the problems which are asked in the examination. Please note down this. This is very important. Okay, you can try this problem at home. This is a one derivation which you need not remember, but it is asked sometimes in the examination. So please do try this at home. Here the formula is gamma D. Gamma D, we also know that, is equals to Gs plus Se is there, so S will be 0 because it is dry condition. So Gs gamma W upon 1 plus E as well. So these are two formulas for gamma D. This is very easy to derive. Just put S equal to 0 in the last derivation. You can find out gamma D value as well as gamma saturated value. If you put S equals to 1, you can also get gamma saturated in terms of Gs and E. Now, next problem is saying that gamma D is equals to Gs gamma W upon 1 plus E. This we already know. we have to do it 1 minus Na. Na is nothing but what? Percentage air voids, is not air content. This is percentage air voids. Okay, 1 minus Na Gs gamma W upon 1 plus WGS. This is very, very important. You can try this at home and you can just look to derive this. This is very, very easy. Just try it once. Okay. Okay students, now let's discuss one previous year's IES question which was asked in civil engineering. Okay, the question says, in a Proctor compaction test, the soil specimen of one observation had bulk unit weight of 19 kilonewton per meter cube, had bulk unit weight of 19 kilonewton per meter cube and moisture content of 15%. And moisture content of 15%. Firstly, what we have to find out is A, find the degree of saturation. Find the degree of saturation of the specimen if GS is equals to 2.7. That is the first problem, that GS we have to find the degree of saturation, which we have to find out. Degree of saturation is we have to find out. In the first case, this is the first problem. What we need to find out is S equal to something. Next is question number B is additional moisture content. Additional moisture content required for saturating the soil sample. Additional how many moisture content you require in order to saturate the soil sample. This is the problem B, which we want is extra W water content. They have asked us to assume gamma W is equals to 10 kilonewton per meter cube. So what are the values given? Let's read the question once again. They have given the bulk unit weight of the soil specimen as 19. So what is the gamma T given? Initially equal to 19 kilonewton per meter cube. Okay. Then what they have given? They have given the moisture content initially. The initial Wi, that is the W1 which is given as initial water content, that is given as 15% or 0.15. Okay. So this is the data which is given to us. Now we have to find out the value of the first case is saturation value. Let's see how we'll be doing. We know that gamma T is nothing but equal to GS plus SE upon 1 plus E gamma W. So in that case, this will be nothing but equal to GS plus WGS upon 1 plus E gamma W. We know that W and we know the GS, that's why I know I have used this particular value as GS is also given equal to 2.7. When you know the W and GS, why not use that? So our gamma T will be equal to GS is 2.7 plus W is nothing but 0.15, that is the W1 which we have to consider initially, and GS is 2.7 upon 1 plus E, and that is given into gamma W. Gamma W is asked us to assume 10, and that is given as 19. Isn't it? Kilonewton per meter cube will cancel the kilonewton per meter cube because these terms are unitless. This term is also unitless. So from here, I'll get the E value. The E value will be nothing but 0.634. Now I got my E value. Now why I wanted the E value is because here we are studying limited system. Here we are studying limited system that is having initially water, soil solid and air, and here our net volume V is fixed. So our net system cannot increase beyond this level. We will study this thing, but when are we increasing this thing? When the water is increased or the net addition of water is in beyond this air level. But now as a limited system, we will fill the water up till this point, and this can also only become water. So the voids are constant. The net volume of the system is not increased. The volume of the system is constant, therefore volume of the voids will be constant, and therefore the void ratio will be constant. So now this E can be used in the next part also. Now before that, we have to calculate the value of S. Now I got the value of E, so we very well know that SE is equals to WGS. So S will be nothing but equal to WGS, which is nothing but 0.15 into 2.7 divided by E, that is 0.634. This is coming out to be 0.638. This is my saturation value. Now, next question is that they are saying that what is the extra water content that is to be required in order to get the net saturation in this particular case. So here we very well know that now as we add water, the saturation will change and the water content will also change. This is nothing but my S1, you can say. Now in the second case, I'll be finding out the new thing. This is now my for case 1, this is B. Let's take the part B now. Now in the next part also you can apply SE is equals to WGS. So I'll write down S2 into E is equals to W2GS. Now S2 is equals to 1, obviously, because they are saying that the system is now saturated. So what will you do? You will simply write S2 is equals to 1. So if I replace S2 by 1, I can very well find out the new W2, because E is constant, that will be this value only. So my formula will now be E is nothing but 0.634 by GS is nothing but W2. So W2 will come out to be 0.634 divided by 2.7, that is coming as 0.235. Okay, so now if we subtract W2 minus W1, I am getting what? 0.235 minus 0.15, that is coming out to be 0.08, something like that, 0.08, something like that. Okay, so this will be nothing, you can say that 0.85 that can be said. So this will be nothing but equal to 8.5%. Okay, this is very easy to understand, very easy question given. You just have to keep your cool in these questions. These are generally for 2 marks. They can be applied in feeding type problem as well, where you have to fill this value. Okay, this value should not deviate in some order. It cannot be going more than 10, or there should be at least 10% here and there they allow. But you have to keep everything accurate. Use the calci, try solving problems on the gate calci. That will help you definitely scoring good in the gate examination. Start from today. Start solving the problems today itself by the using gate calci. Leave your general scientific calculator. Okay. Okay students, now let's look at the next problem, that is from the GATE 2014 set to 1 mark civil engineering. So the question says that a certain soil has the following properties. GS equals to 2.71, porosity, that is eta value, is given as 40%, W is given as 20%. So our GS value is given as 2.71, W is given as 20%, and our eta is given as 40%. We have to find out, the question says the degree of saturation of soil, degree of saturation of soil rounded off to the nearest integer, rounded off to the nearest integer is, okay, so rounded off to the nearest integer is, that is very, very important, and that too in percentage they are asking in the saturated value in percentage. So how will you do it? This is very, very important, very, very easy as well. So what I'll suggest you is, firstly you have to calculate the E value. So we very well know that eta is equals to E upon 1 plus E. So we have to find out, eta is given, we have to find out the E value. So E will be nothing, 1 by eta will be nothing but equal to what? 1 plus E upon E, that will be nothing but equal to 1 by E plus 1. So 1 by E will be nothing but equal to 1 by eta minus 1. Therefore E will be equal to eta upon 1 minus eta. So E will be nothing but equal to, eta is given as 40%, that is 0.4 divided by 1 minus 0.4, that is coming as 0.4 by 0.6. This is my eta, that is coming as 0.67. That will be nothing but 2 by 3. 2 by 3 is nothing but 0.67. So I got my E value. Just put accurately 0.6666. Don't mark in such a way that you have, because they are asking in nearest integer. So be accurate as much as you can. Okay. So try to write it 0.666 like this. Okay. So now I want to find out my S value. S will be nothing but WGS upon E. So W is given as what? 0.2 into 2.71 and divided by 0.666. So this will be giving you answer about 0.813. This will be my saturation, and that is equal to 81.3%. In percentage it is 81.3. So we have to round it off to the nearest integer. So as it is 0.3, so it will be rounded off towards 81%. It cannot be rounded off towards 82, but they will be giving you a range between 80 to 83 or 84. So you might get into the answer if you have taken somewhat approximations as well, but I will still recommend you to try to make it as accurate as possible so that you do not lose out on easy 2 marks or 1 marks in the examination just because of approximation. Okay. Okay students, now let's take out the next problem, that is from K 2013. The question says, in its natural condition, a soil sample has a mass of 1.98 kg and a volume of 0.001 meter cube. Let's write down whatever it is given. So in the natural condition, so natural condition is weight of everything, weight of that in natural condition. In natural condition is given as 1.98 kg and the total volume of the soil is given at 0.001 meter cube. Okay. Next, after being completely dried in an oven, the mass of sample is 1.8 kg. So what is that? Weight after drying is given as 1.8 kg. Okay, we have given as 1.8 kg. Specific gravity GS is given as 2.7, and they are asking us to assume gamma W equal to 10 kilonewton per meter cube. They are saying that the specific gravity is 2.7, unit weight of water is 10 kilonewton per meter cube. The degree of saturation is, we want to find out the degree of saturation, which should be pretty easy as a lot of values have been given. But we have to be very smart in answering these type of problems. So see here, what we can say is that this is a natural water, natural weight. Natural weight, what will be happening is, there might be water also present, and after oven drying it, so the net weight will be nothing but of only soil solid. This will be nothing but weight of total soil solid only. So if, and what is the weight of water? That will be nothing but weight of natural content minus WT. So can we find out the moisture content or the water content? Very nicely, we can very easily find out. That will be nothing but 1.98. The natural weight, that is nothing but total weight only. If we subtract from that the dry weight, that is nothing but the weight of solids, 1.8. So divide by W, this is nothing but the weight of water, isn't it? And divided by what? Initial weight. That is nothing but only soil solid weight, that is 1.8. So this will be nothing but 0.18 divided by 1.8. This is coming as 0.1. So 10% is the moisture content. We can very easily calculate. Now, what I want is, I want to calculate the saturation value. So initially, can I calculate the gamma T value? Why not? We can very well calculate gamma T will be nothing but equal to GS plus, I am writing down WGS upon 1 plus E can be written as what? WGS by S into gamma W. What is the gamma T initially? Net weight is 1.98 kg upon, what is the value? Volume, total volume is 0.001 meter cube. This is kg by meter cube. I have to multiply it with 9.81 to convert it into kilonewton per meter cube. This will be directly converted to kilonewton per meter cube because mass, this will be Newton per meter cube. So I have to also multiply. This will be nothing but my total Newton. This is mass mg. This is nothing but upon meter cube. This will be nothing but giving me Newton per meter cube. That is very important. This will be nothing but multiplied by 10 to the power minus 3 also to convert into kilonewton per meter cube. So this two will cancel out each other. Now this is nothing but what? Gamma T is equal to GS is given as 2.7 plus W is 0.1 into GS is again 2.7 upon 1 plus 0.1 into 2.7 divided by S. So only one variable is left, that is S. So S will be nothing but equal to, we can very well calculate from here, that is S is coming out to be 0.54, which is very easy. Okay, this is how we solve these kind of problems. It is just the manipulation of SE is equals to WGS and gamma T is equals to GS plus SE upon 1 plus E gamma W. If you remember these two formulas, we can solve any problem possible in soil mechanics. I've told you, just remember these two formulas. This is more than enough for solving any problem in GATE as well as PSUs, or also in ESE, that is the Engineering Services Examination.